Before we start today's lecture, I just want to remind you for the last time that there is 4 days from Wednesday to the deadline of Project 1. So if you are still not started yet, this is your last chance. If you have already finished it, I encourage you to use these 4 days to further improve your implementation, because it at least lead to a possible 20 points of your project, which means 5 points to your total final mark of this course. So it definitely was a try. If you got any questions, ask it on the forum. Also, I just want to emphasize again that don't post your code on the forum, because we won't be able to check it for you. I have explained why on Monday's lecture. Alright, so let's start today's lecture, which is about Spark SQL. Right, so the first question would always be the motivation, or why we need Spark SQL. Why people create this and why we learn this. So basically, a table is one of the most commonly used ways to present data. It is also known as structured data, or it's a representative of structured data. So there are some many advantages of table data. For example, it is easy to scan, easy to analyze, and you can do filter or sort or many other operations on it. You probably have already got the sense or the feeling in from other courses, especially 9311 database systems. And also, table is widely used in many areas, such like communications or research and data analysis. And table has a relatively stable data structure. It is 2-dimension. When we talk about table, we always assume it's a 2-dimension. So it has row and column. Right. Usually, for each row, it represents a tuple or an entity or a object. Tuple is more general concept here. For columns, for each column, it represents a attribute. Right. Then the cross of row and column would be a specific attribute in regarding to a specific tuple. Right. And also with this predefined attribute types, also known as schemas, or part of the schemas, schema information, we can perform queries, SQL queries on top of it to generate new tables or to extract information that we need. Right. So so far we have discussed the advantage of table data, and in general, if you can customize something or specialize in an area, then it would be better. So Spark is more like to handle a general case. So we don't know what the data is or what is in RDD. We only know that it is key value pairs. But if we have some information, for example, we know it is a table, then we can actually do things more efficiently, as we will see in today's lecture. So this is the motivation of Spark SQL. So basically, we want to create a customized platform or tool for this specific data structure. Right. So what is Spark SQL? Right. It is part of the core distribution ever since the first version of Spark from April 2014. Right. Spark SQL tightly integrated. Spark SQL is a tightly integrated way to work with structured data. So by structured data here we mean the tables, right, with rows and columns. So the basic idea is to transform RDDs using SQL or the method or operations that are similar to SQL. So as we will see later, I mean, there are two ways to transform these RDDs. One is to use SQL queries, and another way is to use data frames. So at first, there is no data frames. Data frames was introduced to Spark within a later version, but it is more commonly used today. Right. So, but the general idea is the same. We transform the RDDs using a SQL query or methods that performs equivalently to a SQL query. And the data source integration. So for Spark SQL, we have we can integrate data from different data sources. Includes Hive or Parquet, JSON, CSV, or even Python list if we're talking about PySpark, or RDDs as well, or text files, right? But one of the most important concepts here is that Spark SQL is not about SQL. It's more like, so the aim of Spark SQL is to create and run Spark programs faster, given that we know the objective or the RDD is a table. I mean, it still has the fundamental difference from a SQL in database manager systems. All right. So this is an example of using Spark SQL. So here we use this is how we compute an average, and on the left-hand side was the code written in Hadoop, MapReduce. Right. We haven't taught about this ever, but as you can see, you need to write your own map and reduce functions, and you need to design the whole things. But if we use RDD, here we actually these three lines were the it is the essential part that we have been doing. But still, I mean, we need to write our own functions for map and reduce by key operations or methods. We will discuss it later here. I do have some comments on this. But let's look at this first. If we use Spark SQL, then it is pretty easy to do it. So basically, we just group by name, because this example I think is the same as, at least the data is the same as in the assignment. Right. So basically, we group by name and do average on score. And if we do the collect, then we would get something like this. Now here, because we did get some feedback that the lambda function is not very readable or a little bit hard to understand. Also, maybe maybe difficult to write for some of you. So here I just want to say a little bit about this. So first of all, it is just one of the few choices, right? As I showed, you can actually use write your own functions, not using this lambda function formulation, right? And in order to understand this, we need to know what is the input parameter for map, and for example in this case the map and map reduced by key. So for map, the input is what you see in the raw data. So it is a tuple with 3 elements, right? The name, the cost, and the score, right? So which corresponds to the x represents the tuple here. So x0 is the name, x2 is the score, because we want to compute the average, so the cost doesn't matter. Then for this map, we just convert a tuple into we convert the tuple into a name and a score and one tuple. So the key would be the name, and the score with a 1 would be the value. And for reduced by key, we have 2 inputs, right? We have 2 inputs, and because this is reduced by key, so the key really doesn't matter. That's why these 2 input parameters would be the value from 2 different key value pairs. So for example, it could be Joseph, it could be 83.1 and 47.1. And here we just add up the scores and the count. And for the last map, here the input would be a tuple again. So it would be something like Joseph. He should be the sum of his scores. So it's 330, and also the number of courses, right? And this 2 is in a tuple. So that's why we have x10, which is this, the total score, and x11 would be the counter. All right. Then you do the division, you get the average score. So here, all I want to say is, in order to understand this, you need to know what is the input parameter, the input data for each and every methods here. And for different method, the input would be different. But if you know exactly what the input is, the lambda function is not that hard to understand. All right, so that's to answer a previous question. And now here you may have seen this df, which actually stands for it's a variable name, but it actually stands for data frame. And I have also mentioned here, right? So basically, data frame is currently most commonly used way to manipulating data. Right. So let's look at data frame. So a data frame is a distributed collection of data organized into named columns. There are several information in this sentence. So it's a distributed collection that is, because we're talking about Spark, so it is distributed. That's why it can make use of different workers, could speed up the procedure. Right? It's a collection of data, definitely. It is organized into named columns. Right? We will discuss this part later. All right. But for now, just keep in mind that there are something strange here. I mean, what is named columns? What does this sentence mean? We will discuss it later. So the data frame API is intended to enable wider audience beyond big data engineers to leverage the power of distributed processing. So basically, they create this data frames API just to make things easier, right? To make Spark SQL more easy to use even for those who are not specialists in big data or in Spark. It is inspired by data frames in R and Python. Well, in Python, the data frame is actually the module is called pandas, and pandas is a really popular and useful module for data processing. I mean, it's also designed for table data as well. It is good for table processing and visualization, and it is fast on a single machine. Actually, it is faster on a single machine compared to Spark SQL, because in Spark SQL we have this DAG, and we need to design the plan, which we will discuss later as well. So all these things also have their overheads. So pandas would be even better for use on a single machine. The data frame API is designed from the ground up, support modern big data and data science applications. So it does have a functionality, a comprehensive functionality to handle different situations or different demands of this big data and data science applications, which you may have seen a little bit later, but you will see more if you get into it. And most importantly, it is an extension to the existing RDD API, which means data frame is nothing but RDD. It is still RDD. All right. We will see later as well. I mean, there are certain differences between data frame and RDD, but basically, data frame is still an RDD. So the RDD API can be applied on data frames, but not the other way around. All right. And data frames has the following features. It has the ability to scale from kilobytes of data on a single laptop to petabytes on a large cluster. So it can handle different size of data, especially big data. It supports for a wide range of data formats and storage systems. For example, we have for the data formats, there are JSON, CSV, or RDD, or as we have mentioned a lot before. And for storage systems, the HDFS and other storage systems as well. Data frame is the state-of-the-art optimization and code generation through the Spark SQL Catalyst Optimizer. The detail about this Catalyst Optimizer, we won't discuss it in this course. But if you are interested, I mean, you can find the resource of it, and we will discuss how, in general, I mean, how the Spark SQL is executed or planned and executed with the help of this Catalyst Optimizer, and hence the data frame has benefited from this. Right. This is for the optimization. And data frame is seamless integration with all big data toolings and infrastructure via Spark. And also the API, there are APIs for Python, Java, Scala, and R. So basically, every programming language that is supported by Spark, you can use data frame as well. And so to conclude, data frame for new users that is familiar with data frames in other programming languages, this API would make them feel at home. So basically, the API is quite similar, for example, to the Python Pandas API. For existing Spark users, this API would make Spark easier to program, and also more efficient as well. And for both sets of users, data frames will improve the performance through intelligent optimizations and code generation. So as we have mentioned, explained why before, and we will see how it works later. Right. So data frame data sources. So with this Spark SQL's data source API, it can read and write data frames using a variety of formats. Right? For example, the structured data files, tables in Hive, or external databases, or existing RDDs. As you can see here, I mean, all different kind of data types that are supported by Spark SQL and this data frame. Right. Well, now let's look at some very simple examples about data frames and Spark SQL. Then we will dive into some details about, for example, how the data is stored and how the action or the SQL query is executed in Spark SQL. This is the second part. And the third part would be, let's see some fundamental operations in Spark SQL and for data frame to see how, if we want, how do we program in Spark SQL. All right. So let's start from this example of data frames first. So here, the first thing is to create a data frame. In order to do that, we need to initialize a Spark session. So the Spark session is the entry point to programming Spark with the dataset and data frame API. In Python, there is actually no dataset thing. That's why we never mentioned this before. Dataset is a data type in for Java, for Spark in Java and Scala only. All right. So in Python, we only focus on the data frame API. All right. So that is here what we have been doing here. So we initialize a Spark session, and then we create this is an example of how to create a data frame based on the content of a JSON file. So we use this read method where we state the format of the data and the path of the data. So then we load it as a data frame. Right. So if we want to display the content of the data frame to the standard output, we just use df.show. We will see. We will talk about this show function later. But in general, it will output the content of the data frame. it is just like what you have been seeing in, for example, Postgres SQL. The output style would be quite similar. All right. And here are some data frame operations. For example, our print schema. You can see the schema of the data frame, or the select here. You select a specific column or columns, and you can select everybody with its name and its age +1, right? So it's just to give you an idea of how to program in using a data frame. And as you can see, it is quite, first of all, it is quite easy, and the code would be much less than you used to do for PySpark. And if you are familiar with pandas, then you will see that it is really similar to pandas code, and the code is more readable and easier to understand, right? And you can do select people older than 21, so it is basically a filter, similar to where in SQL. And you can do group by and count, so use this kind of aggregation functions. Well, these are all basic operations, data frame operations. And the data frames are fundamentally tied to Spark SQL, which means the data frame API provides a programmatic interface or a domain-specific language for interacting with your data, and the Spark SQL provides a SQL-like interface, right? And what you can do in Spark SQL, you can do in data frames, and also what you can do in data frames, you can do it in Spark SQL. As we can see from all these previous examples, here is essentially what we're doing is just to select age name where age is larger than 21, right? And here is just a group by age and the count. So each and every data frame operations here, you can find corresponding SQL operations. So that's why we say that it is fundamentally tied to Spark SQL. And if we look at Spark SQL, we'll still look at some some simple examples and definitions. So Spark SQL allows you to manipulate distributed data with SQL queries, just SQL queries as SQL queries in database. So you issue SQL queries through a Spark session using the SQL method or SQL method. So this method enables applications to run SQL queries programmatically and returns the result as a data frame. So the result would be a data frame, which is an RDD. So still, everything is RDD, right? You can mix a data frame method and SQL queries in the same code because they are essentially is equivalent to some extent. Right? So if we look at the example here, all you need is to call this SQL method and put a SQL query in the method. in the method, and then it's just like you execute a SQL query with in this table. But in order to do that, we need to create a SQL view. Here we just use a temporary view. So the temperature views are in Spark SQL are session scoped and will disappear if the session that creates it, which is the Spark session here, it will disappear when the session terminates. But we do need this temporal view to get to initialize a table. So the method would be a register temp table, and this table is just a SQL view of this data frame df. Right, then you can apply a SQL query on top of it. So here this people and this people, I mean, this is where this people comes from. Right. So far we have discussed Spark SQL and data frame in a very general scope. Right. It looks like a little bit well, how to say, we kind of jump between Spark SQL and data frame. But the thing is, as we have mentioned here, they are fundamentally tied together, right? And it is hard to talk about Spark SQL without talking about data frame, and also the other way around. So anyway, by now we have discussed the motivation of Spark SQL. We have briefly introduced the concept of data frame, and so basically Spark SQL is more like an ecosystem of Spark, right? It provides a SQL-like interface, and the data frames is a fundamental API or the entry point to the data that you can manipulate in data through data frames. Although, I mean, the Spark SQL actually offers a SQL-like interface as well. But arguably, data frames, the interface offered by data frames is more readable and easy to program. Right. We have also see a short example, right? So now let's start to discuss some details in Spark SQL and in data frame. So we start from data frames, from the operations to how it is stored, and then we will discuss the query execution on Spark SQL. Right. So first of all, I mean, data frames are RDD, right? So the RDDs is lazy evaluated, as I have mentioned this quite a couple of times. And also, this is related to your project 1 as well. So basically, in the context of Spark SQL, the transformations contribute to the query plan, but they don't execute anything. When you do the execution, is when the action is called. So actions cause the execution of the query. So here are some examples of commonly used transformations and actions in the data frame API. So for transformations, we have a filter. It's more like a where in SQL. Select is select. Drop and intersect and join. And for the actions, we have count, collect, show. You have already see head and take. I mean, some of them are actions of RDD, right? Some of them are actions for data frames only. For example, show. This lazy evaluation thing is very important, as you will see later, that it gives the Spark SQL the chance to do the query planning when the query is about to execute. If we don't have this lazy evaluation property, then you can imagine if every step we type a transformation, then it will be executed. Then there is nothing called query planning, right? So so we don't have the chance to improve the efficiency of the query. So just keep it in mind, and you will see how it helps Spark SQL later. Right. And the other thing is the storage. So data frames use columnar storage. So basically, it is just a transpose of a row-based storage. Right? Data in each column are packed together. For example, here, row format or row-based storage is the most common way that we have been using. For example, the example here, this is an example of row-wise storage. As you can see, it's a list of tuples where each tuple corresponds to a row in the table, right? And if you do the partition, of this data, you would see some of them, for example, from here to here is one partition, and from here to here is the second partition, and the rest is the third partition. So each partition you have multiple rows, multiple tuples or multiple rows, right? And in data frames, it is different. So we pack each column, data in each column together. For example, we pack 1, 2, 3 together, and Mike, John, Sally, and this 4.1, 3.5, and 6.4. By together, I mean if we, for example, we partition this into 3 partitions, then this would be the first partition, this would be the second, and this would be the third. Right. And that you may have noticed that in this way, in each column, the data would be the same type. For example, they are all integers here, strings here, and floats here. Right. This columnar storage have a couple of advantages, especially for distributed data storage, for distributed systems, and for Spark SQL that we're going to discuss. All right, so here are the I just list some of the advantages of using this columnar storage. For example, first one, data access is more regular. For example, we have a column of integers, and if we want to access the third one, if I want to access the third one, because we know that each integer is 4 bytes, So it is I can quickly compute the offset of this element and directly gets the number here. But yeah, let's see if in row format here we let's see if we want to get the third row or the third column in third row, right? Again, the float is 4 bytes as well. So if we can compute the offsets as well. But if we do the row form, if we store it in the row format, then we don't know we can't know the offset because we have a string column here, and the length varies, right? So we would need some complicated offset computation to know where to get the number or where to access the number. This is the first point. The data access is more regular. Secondly, denser storage. So basically, data frames, this columnar storage offers the chance to store data in a more denser way. This is because the nature of the data is homogeneous, which means the data, they all have the same type. They all have the same type, which makes it possible to apply a better compression techniques according to the data type. Then we can use less space to store more data. The third one is compatibility and zero serialization. For example, most of the Spark SQL plan is evaluated in Spark, and at the end of it, we want to call, for example, we want to call it TensorFlow, right? When it is done, because we get the data out, we ultimately we want to plug it into some applications or into some other modules. So we use TensorFlow as an example here. So if we use columnar in memory format, then it is compatible with TensorFlow, for example. So we don't need to do serialization to make it compatible with TensorFlow. So this is another advantage. More extensions to GPU or TPU. This is because, for example, in nowadays, the machine learning applications usually running on GPUs because they are very data intensive, and we all know that GPUs are more powerful than CPUs especially for homogeneous data. So that's why having this homogeneous columnar storage gives the chance to offloading the process to GPUs and CPU or even TPUs, and to use its advanced hardwares. So it is more extension to GPU or TPU. The efficient query processing. For example, we have 2 tables where each table has different columns or different attributes. If we use columnar storage, then each column would be stored together. But if we use row-based storage, then let's say we want to do a join of A4 and B4. then we need to get data. If we do a row-based storage, then we need to access each and every data, just to take one or two columns. Let's say if we do a join here and we do a select of A1 and B1, so we need to access all the data, but essentially we only need say this 4 columns. That is what we need. So if we use this column-based storage, then we do not need to access those irrelevant columns. Means there is no network communication overheads or less network communications, which would make the query processing query run faster. All right. This is just a small example, but you have already able to see the advantage of this columnar storage on data frames, right? And even there is a single query, there is a single table involved in the query, SQL query. It is the same or similar. I mean, because usually the query won't involve all the fields or all the attributes, as you if you have used SQL before. Usually you select several columns or attributes or fields, right? So if we store them in this columnar storage, basically each column would be stored separately in different machines or workers. So the total number of workers involved or data nodes that involved would be much smaller. Much smaller. So the I/O and network communication is minimized. Well, it does not mean that columnar storage have no flaw or no disadvantage. So the major problem is that it is not good for transactions. By transactions is that, for example, we add one more tuple or record into the table. Then we need to operate on each and every column, which means which involves all the data nodes that contains part of the table, right? But on the other hand, the row-based storage, it actually favors the transactions, because it's just you just append the new tuple or record at the end of the existing table. Right? But in Spark, considering the application scenarios, there won't be many transactions. Right? Instead, because we usually use Spark SQL to analyze the data or to manipulating the data, so the transactions would be much less than a DBMS, right? So, which makes this columnar storage more suitable for our scenario. So let me have a break, and we will come back and finish the rest part of today's lecture.